All right, time to kick off our DAX demos. Now we're going to start by focusing on calculated columns first, since they're a bit more user-friendly, a bit more intuitive, and we're going to kick it off with basic date and time functions. So here's what we're going to be dealing with. Now all you Excel users, this should look really familiar. These basic date time functions are very user-friendly, really simple syntax, so this should be a breeze. Starting with day, month, year, I call these component functions because they essentially point to a date and extract some specific component of that date, the day, the month, or the year. So syntax-wise, incredibly straightforward. You just point it to a column containing your dates and you're good to go. Same thing holds with hour, minute, second. The only real difference is that you have to point to a column with a date time component as well, because what these hour, minute, second functions do is they ignore the date and only focus on the hour, the minute, or the second of the timestamp component. Now today and now, those are volatile functions, which means that they update or refresh every time there's a workbook change, and those two functions return the current date or the current exact time, respectively. Syntax-wise, literally could not be simpler. This function doesn't even take a single argument. You literally open and close the parentheses, and you're all set. Now, weekday and weeknum, two of my favorite date functions here. Weekday returns a weekday number by default from 1 to 7, representing Sunday to Saturday, and weeknum captures the week number of the year. So for syntax, first argument is the date column, second argument is the return type, and this is where you can tell Power BI exactly how you want your weeks to start, whether it's a Saturday, a Sunday, a Monday, etc. Now, EO month, another really helpful one. I believe it stands for end of month because it returns the last day of the month, plus or minus a specified number of months. So here's what the syntax for EO month looks like. You point to a start date, and then you specify that number of months. So if you use a 0 for the second argument here, the EO month function will essentially give you the last date of that current month. If you use a -1, it would give you the last date of the previous month, and vice versa. Now, a little pro tip here, even though it's a bit of a misnomer, you can use the EO month function to return the beginning or the first of the month as well. I don't believe Power BI or Excel have any first of month equivalent functions, but what you can do is set that month's argument to -1 and then simply add 1 day, so +1, at the very end of the function. That basically calculates the last day of the previous month and adds 1 more day to give you the first date of the current month. And then last but not least, we've got date diff, returns the difference between two dates, but not only that, but it allows you to select a specific interval as well. So date 1, your start date, date 2, your end date, and your interval, which gets as granular as seconds or as broad as years. So a really helpful function for calculating the difference between two dates. With that, let's open up our AdventureWorks file and start adding some new date and time columns to our model. All right, so once you've opened up your AdventureWorks report, let's navigate to the Data tab. This is going to be kind of our home base for the next few videos as we create these calculated columns and measures to our model. And now make sure you're following along because we're going to be creating new fields, new measures that are going to be important for us to analyze and visualize once we get to the next section of the course when we start building reports and dashboards. So pay close attention, try to follow along step by step. Now the first demo that I'm going to use is the weekday function. So I can right click anywhere inside this table, really doesn't matter where, select new column, and it'll just tack that column right to the end of the table. So let's go ahead and name this day of week, and we're going to use the weekday function here. So as we start typing, you'll see that not only does the formula or function name populate, but a description populates as well. So really helpful tooltips and IntelliSense functionality that Power BI offers here. So I could tab to lock that in, and it takes me right to the first argument, which is the date. So let's go ahead and start typing to find that field. You can either type date, which gives us the option there, or we type calendar to navigate to the table. Either way, it helps us find it. And then again, I can tab or double click to select that field. And now with date field specifically, this additional list of options appears. .date, .day, .month, and so on all the way to .year. And this is Power BI being pretty slick. It's saying, okay, I see that you selected a date field because it knows that calendar lookup date is formatted as a date. And it's giving us the option to either use the actual date itself by default or to use some aggregated component of the date like the month or the quarter or the year, just like those day, month, year functions actually work. But it's kind of embedded in here, which is pretty clever. Now, I don't have to select any of these options, or if I select .date, it would be redundant, but basically the same thing. In this case, I want to reference the actual date itself, so I'm just going to press comma, and it takes me right to the next argument of the function. Now remember, this is the optional component. The return type, you can see that it's optional because it's shown in brackets in that tooltip. And my options are 1, 2, or 3, where 1 is a week starting Sunday, 2 is a week starting Monday, and 3 is another week starting Monday, but from 0 to 6 instead of 1 through 7. So I kind of like defining my weeks starting on Mondays. So let's enter the 2 here, close the function off with a closing parenthesis, and then press enter to lock that function in. And there you go. You see we get 1s through 7s, where 1s are my Monday rows, 7s are my Sunday rows. So there you have it, pretty straightforward demo of the weekday function. Next up, let's actually collapse the calendar and navigate to our customer table. I'm going to scroll all the way to the right here. And you'll remember we have this birth year column, which we had actually calculated within the query editor. So we don't see any kind of DAX formula here, even though that was technically a calculated column. So what I'd like to show you is how we can create that same birth year column using DAX and then remove the original. So again, right click anywhere in the table, new column. I'm going to name this one birth year underscore CC for calculated column, just so that we can compare the two side by side and differentiate them. So birth year CC equals the year of the customer lookup birth date column. So I'll tab to lock it in, close the parenthesis, and press enter. And now when I scroll over, there it is, birth year CC against the original birth year. It all lines up, which is good. And you may have been wondering, can't we use that shortcut Power BI tip that automatically extracts the year without even writing a function? Well, yes, you're very sharp. You sure can. Let's go ahead and edit this, and I'll show you how to do this exact same calculation using a different type of approach. So instead of using the year function explicitly, what if we just point to the birth date field and then use Power BI's tip and say, just give us the birth date dot year, or just the year component of that date field. Press enter, scroll on over, and what do you know? Gave us the exact same correct values. So it's technically a third way to accomplish the same thing, calculating the birth year using the query editor or using both of those DAX or function approaches. Now, I want to show you one other interesting thing, which is obviously we don't need two birth years here in this table. So watch what happens when I right click and delete the birth year column. Okay, so remember that birth year column that I just deleted, that column was added, it was calculated in the query editor. So there was an applied step that added that calculated column to the table. So now what you might be wondering is, every time we refresh this customer table, isn't that birth year column just going to keep appearing and appearing and appearing? And the answer, luckily, is no, because Power BI is very smart. Let me go to Edit Queries and navigate to that customer table, and check it out. It removed the birth year column as a new applied step so that it's not going to keep recreating that column. It knows that we just deleted it from the table itself in the data tab, and so it saved us the trouble of having to delete it over and over and over. Now, the last date time demo that I want to show you, a formula to calculate the current age of our customers. So let's stick right here in our customer table. And for this one, let's practice the date diff function. So let's right click, new column. We're going to name this one current age equals, and we're going to start with the date diff. I'm going to arrow down and tab that one in. And now remember, 3 arguments: date 1, start date; date 2, the end date; and interval. So our starting date is the customer's birth date. So there it is, customer lookup birth date. I don't need any of these time components here. And then the date 2, the end date, is going to be the current date. So I'm going to use the today function, open close parentheses for that one, and then comma to my last component, the interval. And this says, okay, by default, I'm going to return the number of days between the 2 date arguments, the start date and the end date. In this case, we're looking for the current age in years, so we can just scroll right down to year, press tab to enter it, close the parenthesis, and press enter. And we scroll on over. There you have it. We've got current ages, 70, 69, 67, and so on and so forth. So a great way to use the date diff function in that example. And now just for fun, I'm curious, if we change that last interval component, I wonder how many seconds old these people are. So you can close it off, change year to second. And there you go. It looks like our first customer here, Blake Flores, is just under 2.2 billion seconds old, which is not very helpful for the purposes of our analysis. And I don't think our AdventureWorks clients are going to care much about that, but kind of interesting to see. So let's go ahead and change that back to year, close it off, press enter, and now we have more appropriate ages there. So there you have it, just a little sampling of some of those basic date and time functions. We practiced weekday, today, and date diff. Next up, we're going to talk about logical operators and some conditional if, and or statements. Stay tuned.